Hey guys, today I'm going to be teaching you how to build a 2-inch piston valve. Now, most of you probably have no idea what a piston valve is. So basically, it's a valve that uses a piston to seal a seat inside the valve, and then it uses a pilot valve to trigger the opening of the piston and releases the air at a very high speed. This is all happening within milliseconds. So it's important to understand how they work before you jump into building one. So what you should do is jump to the end of this video where I'll show you the completed valve and the internal workings and the physics behind it working and all that good stuff. So jump ahead and watch that part, and then come back and watch step 1, which will be the tools and materials required to build your piston valve. Now, a piston valve isn't too complicated or expensive to build. All the parts I picked up for about $22 or $23, and it can even be built cheaper if you get creative with it. So the parts you're going to need are a 2-inch T, and this is an important part because it's the main housing of the valve. You can get one with no threads on the bottom like this, and that means your chamber, which is going to go in the bottom port of the T, will not be removable or anything like that. You can't use interchangeable chambers or anything. You're stuck with the same chamber. So I would recommend picking up a T with threads on the bottom. I only used this one because the store didn't have any with threads. So anyway, 2-inch T. Then you're going to need a 2-inch female adapter, and you need a female adapter instead of a coupling because the piston's going to be inside this pipe, and you want the back to be able to be unthreaded so that you can take out the piston and service it when you need to. And on the other side, you're going to need a 1.5-inch female adapter, and that's basically the main fittings of the valve. And for pipe, you're going to need 2-inch schedule 40 like this, and 2-inch schedule 80, and that fits snugly around the 1.5-inch. I'll explain this in a second. So you're just gonna need a little bit of that, and you're gonna need schedule 40 1.5-inch. The reason I have this piece of 2-inch schedule 80 is because it's thicker than schedule 40, so that allows you to use it as a 2-inch to 1.5-inch bushing, because 1.5-inch pipe fits right inside of it smoothly. And you need a 2-inch by 1.5-inch bushing for the T, because what happens is the bushing goes in, and then your 1.5-inch pipe is inserted into the T, and it goes in halfway, and then of course your female adapter goes on there. So instead of using a bushing, we use this schedule 80, because if you look at a bushing, it has this little lip on the inside of it. See that? And that keeps the pipe from going too far in it, and that's exactly what we want to do. We want the pipe to go in too far. So if you can't find 2-inch schedule 80, it's kind of rare and hard to get in some places. The only reason I'm using it is because I had a little piece laying around. So if you can only use a bushing, then you're gonna have to grind out the lip on the inside and sand out the inside of it a little bit so that the pipe can go through it smoothly like this, because it's gonna be a lot easier to make your valve if you can slide it in easier. Alright, so that's all the parts you're gonna need for the valve housing. And now for the piston itself, it's going to be a little more complex. Here's my piston. The O-rings are off it right now, but each of these O-rings goes in this little seat right here. So what it is a 5/16 threaded rod, and this is 6 inches long. I got it at the hardware store. It's going to be cut shorter later because these are too far spaced. It needs to be closer over here, so it's going to be cut down. But anyway, these larger washers here and here are 2 inches wide, and so are these, and so is this one. And then we have a rubber washer here, and this is to seal the piston against the 1.5 inch pipe on the inside of the T. And then we have a metal washer that is smaller than the inside of the 1.5 inch pipe. This is so the rubber can seal against it. And then we have a nut. And over here, these are 2-inch metal washers, and we have nuts on both sides. And then in between the 2-inch metal washers, there are 4 other metal washers that are 1.5 inches in diameter, and these are to space apart the 2-inch metal washers enough so that the O-ring floats in the groove. And you'll see this floating effect when I put the O-ring on. Okay, so you can see how the O-ring isn't solid in its groove, it can move. And then you'll see there's 2 of those setups. And then you'll see that on the front O-ring, or the front metal washer, there's a little groove cut in 2 spots across it. You'll see both of them right there. And that is so that when you're filling it, the O-ring won't seal on the front metal washer, and that lets air flow past the piston and go into the chamber. So the piston is right there, and you're going to fill it up from the back, and the air is going to come in and go into the bottom port, and then the front of this piston is going to seal against the pipe in there, and that's what allows the chamber to be filled, these little grooves. So once again, there's only 2 grooves on the front metal washers, but not on the back ones. This is known as the check valve effect. Makes your launcher as efficient as possible. Doesn't waste any chamber air when you fire the gun. So yeah, this piston costs like $10 to make all the hardware. I know it's kind of a rip-off, but it's a good piston. So once again, there's 4 1.5 inch metal washers on the inside, and then there's 2 2-inch metal washers on the outside, and those are to seat the O-rings. You'll see this O-ring, of course, goes on this groove. Sorry, I'm doing this with one hand, but you get the idea. So this goes on right there, and that's what your piston looks like. Alright, now I'm going to go over the pipe lengths. For the 2-inch piece, the 2-inch piece of PVC pipe, this piece is 3 5/8 inches. So this piece is going to vary in your valve because it all depends on how long your piston is. But I'm going with a 3 5/8 inch piece. And then for your piece of 1.5 inch, this isn't going to vary. This is going to be, if this isn't the right length, it's not going to work. This piece is also 3 5/8 inches, which is kind of coincidental, but this piece has to be, it all depends on the size of your T, because some manufacturers make their T's different sizes. So this T needs to be inserted halfway in, so you need to measure it based on that. And then for your 2-inch piece, this is the length of the socket depth. So for me, it's just like a little bit over 1.5 inches, but this doesn't need to be flush, it just could be flush to make it look better. So that's the pipe lengths.